Let's look at box plots. Box plots for us, we're going to have those come from our 5-number summary, and we can get that 5-number summary pretty easily through a spreadsheet. So if we have our data and we just ask for the 5-number summary from the spreadsheet, we can do that. Also, I've made a template, a spreadsheet template that one can use to create the box plots, either in Microsoft Excel or in OpenOffice, which is a free spreadsheet, or in LibreOffice, which is also a free spreadsheet. I happen to do it in LibreOffice, but I save it as an Excel worksheet. So we're going to do this slightly differently than your textbook. So if I have a bunch of data, 1, 2, 3, 3, 3, 4, 4, 5. How many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll do 11 of them maybe. Try that. 10 and 11. So I'll do a 6 and a 6. Now, so if I do a 5-number summary, what that means is what I want to do is get the minimum. I would like to get Q1. I would like to get the median. Q2. Sorry, not Q2, that is the median. Q3, and then the maximum. So the minimum and maximum, pretty easy to get off here. I see the smallest number is a 1. The largest number is a 6. Now I go through and I find the median. Well, I need the middle of this thing. I went with an easy way to, as far as odd number of numbers. So if I go here, I've split it, right? I have 5 things on the right side, 5 things on the left side over here. And so the middle number is 3. So I got that right this time compared to the last video. 3. And then I need Q1 and Q2. So Q1, I need to find the median here. There's the median. Okay, I had 5 numbers. I take the middle number. So I find the middle number there. That's a 2. And over here, the middle number is, on the right, is 5. So there is my 5-number summary. And what I do to make a box plot is I simply start, and I tend to do them vertically because when I think about it, it's if I'm doing box plots, the response variable is what I'm using, and that's the y-axis. So I tend to make mine vertically. And so, for this, if this category, I don't know, I did something in this, I got these data from some category 1 thing. So I make my box plot here, 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1. Now, so what I do is I draw a line, so here's category 1. I draw a line from 1 to 6. Okay, so I go from my minimum to my maximum. And you don't have to put little horizontal lines like that, but I often do. Then I make a box going from Q1 to Q3. So Q1 is at 2, and I make this box that starts there, goes up to 5, and then I do that, and see, so here is the min, there's Q1, Q3, and the max, and then I go to the median, which is at 3, and I draw a line through there for the median. And that's what a box plot tells us. Now, I'm going to make a bigger one just to then make the point. But that's all a box plot is it's that 5-number summary from your data, and it's usually drawn like this. Now, the book, instead of using the max and min for the top and bottom of the box. These are also called box and whisker plots because that line is considered a whisker, I guess. But your text, they use a different way to compute the top and bottom. What they do is they go, I think it's, what the heck do they do? They talk about outliers, that sort of thing, and they compute the interquartile range, and so for us that would be 3, because that would be the 5 here minus the 2, so our interquartile range is 3, and they would draw the whisker up 1.5 times that interquartile range, up above Q3 and down below Q1. Okay, so they wouldn't use the min and the max when they do it in the text. Well, I'm not big on pushing this idea of outliers, and so that's just a side thing. There is rare events happen, and so, you know, if you looked at, for instance, for any given lottery thing, because definitely rare events, people winning, say, a big Mega Millions or Powerball lottery, if I picked, like, how much did each person win on a given drawing, well, you know, what would happen, right, is most people would be down here at 0. You know, that'd be probably everybody, probably including the median. I'm not sure on the odds, but it could include the median. So that would squash all of the box up here and this minimum way down, and then you know, and then you'd have this whisker, and if it happened to be a day that they won the jackpot, you know, who knows how much that was, but say that's 40 million. You know, there's your data. Well, according to, you know, and I'm going to draw this wide because it's everything here. In other words, right, 75% of the people maybe didn't win a thing. Now, I don't know if that's really true, but that's what this box plot is saying, is 75% of the people did not win any money. But somebody won, say, $40 million. Well, that's true. That's real live data. I mean, somebody will say somebody won $40 million. Well, according to your textbook, they would want you to call that an outlier and throw it out. Well, in that case, you don't throw it out. It's real live data. You know somebody won. It was published on the website or something like that. The person gets the money, pays taxes. It's real. Okay, it's real. And so, you know, this idea of outliers, people want to throw away data. Well, rare things do happen. And so this is a case where something rare happened, and it is really part of the data. So I don't like that the authors kind of start this idea of outliers, and when you tend to hear outlier, most people tend to think, oh, they can throw away that data. And well, it's possible. I mean, if you do see data points that are way outside of everything else, right? If they look way outside, then you should really go back and look at your data collection techniques to make sure they aren't erroneous data. But if they are not erroneous data, if you can't come up with them being erroneous data, well, then they're part of your data and they should be part of the analysis. And so I go with a box plot that has the min and max in it, not one that does this outlier calculation. So looking at the box plot more generally, so I could have a line there, I have something like this, and so suppose this is my box plot, and let's put the median kind of down here somewhere. Okay, now what you want to realize in a box plot is that 25% of your sample is represented in this little interval. Another 25% is represented in here. Another 25% is represented in there, and then finally another 25% is represented here. Now, to me, this is important in reading the box plot, because if we think about our idea of bar plots and histograms and so forth, what this says is if I were to take this box plot and draw it on its side, now this is the min, remember, and so it was a little longer there, shorter here to the median, and then kind of short there. Now, the important thing to understand here is if I were to make this like the x-axis and draw it there, since 25% is in all of these, if I were to draw a histogram using these uneven pieces, right, because this one's longer than that one, this one looks to be the longest, and that's pretty short too, then it's an area thing, and you should think of, if I were to draw a histogram with this, the areas should all be the same. And so actually the shortest item, and I'm just going to pick a height here, this looks to be the widest right there, so I'm just going to go like that. And there is one of my bars for a histogram or a bar plot that happens to be touching, I guess. But now, this one, right, that's, I just draw one of these, that's my base area. Now, since this is almost the same width, to get the same area, it needs to have just a little bit taller rectangle like that. Now, these other two that are very narrow, to get the same area, well, I kind of think proportion, and this looks to be maybe a third the size, this one is about a third the size of that one, so it needs to be about 3 times taller to get the same area. And then similarly, this one looks, pretty much the same, maybe, oops, I didn't want to go that high. Something like this. But there would be a histogram. Now the bins are not all equal size, so, but if I had bins, I tried to make things all the same size. I might do something like this, draw in there bins like that, and and they're about the same size now. I mean, again, they aren't exactly the same size, but so this is what's happening as far as your numbers. You know, you have, because this is small here, it's actually sort of an opposite idea, is that the the total frequency here is the same as the total frequency here. Okay, 25%, 25%. But that would mean that if I thought of it like bar charts or histograms, actually these narrow ones would have the tallest bars, and the wide ones would have the shortest. Because if I'm going to make these bars each have about 25% of the items, then the wider bar here has to have a lower sort of average frequency across it to get 25% of the numbers and 25% of the numbers, 25%, you know. So, you know, this might be like, now suppose I decided these were all, you know, this height and this height were the same, and this height here and this height were the same, just to make my life a little easier. You know, it could be that I have, you know, like 15 numbers total here, 15 numbers total there, 15 numbers total there, 15 numbers total there, right? That's 25% each. But notice what happens is if this is 3 times as wide, my height here might be just 5 numbers each and 5 numbers each here, but these would have to be 15 numbers each, right? So that's what's happening is I read a box plot. You know, I need to remember that, yeah, there are just as many numbers represented in that little short stick as there are in this wider piece here. And so from a histogram point of view, your histogram would actually look something like this. And so something with that's nice and uniform, I would expect that to have sort of all even segments. I'll put that line through there, I guess. I would expect that to have all even segments. You know, this is the same length as this, is the same length as that, is the same length, as the bottom part. And but if it was more peaked in the middle, I would expect little short whiskers with a bigger box in there. And if my data were actually tended to be out toward the ends, I would expect oops, sorry. This is, see, I did that backwards. I mean, this isn't trivial. So this is even. So if it's humped in the middle, actually here, so I'm going to say peak in middle, right? Because these being narrower in here, they should have the taller parts of the histogram. And then here, most of my data is actually at ends. So data at ends. Okay, so most of the distributions we're going to work with, we will tend to have the hump in the middle, and so our box plots should actually have pretty long whiskers. If we're actually doing box plots, they should have pretty long whiskers with them in smaller boxes. If our data were kind of pushed out to the two ends, not much in the middle, sort of just the opposite of this one over here, then we should see little short whiskers and very big box in the middle. And if the data is relatively even, then we'll see whiskers that are similar in size to half the box. Okay, so I almost really screwed that up on these two, but again, I caught it. Okay, so mistakes, I will misspeak. I mean, the more you talk, the more you're likely to misspeak at times. So I apologize for that, but at the same time, I'm catching the error, and if you think I made an error and didn't seem to catch it, again, ask questions. That's a great way to go. So there's box plots, and I'll also have a video on using the template that I make for you.